Howdy folks, we're going to talk about power. Power is a really useful thing to know about because it is kind of the amount of work that an electrical appliance can do. And we have talked about, we're going to be talking about it in terms of energy and also in terms of voltage and current. Energy is something that you are familiar with. We've talked about it in atomic and nuclear physics in R equals mc squared equation, but now we're going to talk about it in terms of electrical appliances and light bulbs and that sort of thing. So, the equation that governs power in terms of energy over time is this one right here. P equals E over T. E being the amount of energy done in joules, a unit you're familiar with, and time is the time in seconds. Time I hope you're familiar with as well. And when we divide energy by time, we get electrical power in watts. It's important to keep power with the symbol P, but the unit watts, W, separate from work, which has the symbol W, but a different unit. So, anytime we're given an equation, or given some information that tells us two of energy, time, and power, we can always work out the third one using this equation. So, for example, how much electrical energy is converted to heat and light if a 100-watt lamp is turned on for 5 minutes? First we get our equation, P equals E over T. We rearrange it to solve for energy, because we want to know about energy. We get energy equals power times time. Our power is 100 watts. Our time is 5 minutes. 5 minutes in seconds is 300. So that is going to be 30,000 joules. So, pretty simple, just a three-part equation. We can rearrange it. But that's not the only way you can calculate electrical power. You can also calculate it in terms of voltage and current. So power in watts, still same power, is equal to the voltage across a component times the current through a component. So a component is something like a light bulb or a dishwasher or a washing machine or oven or whatever. So just how much voltage difference and how much current goes through it. So for example, if an electric jug is rated at 1.4 kilowatts, that means when it is running, it is using 1.4 kilowatts of power. What current does it draw when plugged into a 240 volt power point? So it's plugged in to the wall, getting 240 volts, and we know that it is using 1.4 kilowatts. So we want to know the current, so we rearrange this equation to give us current, I equals P divided by V. I equals 1400 over 240. 1400 is 1.4 kilowatts. 240 is the voltage. Divide gives us our answer in amps. We take that down to two significant figures because that is the lowest number of significant figures in our given information. So 5.8 amps is the amount of power, the amount of current drawn by that electrical jug. And you can do this for anything with a resistance. We don't know, this equation right here does not include resistance, but it does include V and I, and we know that V and I have a lot to do with resistance from our Ohm's law, V equals IR. So ohmic conductors, that's just any sort of resistor. We can solve for the voltage of an ohmic conductor by V equals RI, V equals IR. We know that the power is equal to voltage times current. We can plug voltage, Ri, into this equation here. So P equals Ri times I, or Ri squared. We can also do the same thing with voltage. Sorry, with current. Rearrange that for current, and then we can get the same thing in the terms of voltage. So power equals resistance times current squared, or power equals voltage squared over resistance. Both of these are true. This one we use if we know the current but not the voltage. This one we use if we know the voltage and not the current. Either one of them will give us the power. Alright, so for example, a hairdryer uses 240 volts and draws a current of 10 amps. Calculate the power rating of the hairdryer. Pretty simple. We will use the equation here, P equals VI, and combine it with V equals IR. We want something that only has voltage and resistance. So we get V equals IR. We solve that for current, I equals V over R, and then power equals VI, so sub that in for I. So in other words, power equals V times V over R, which is V squared over R, which is the same thing we had right here. And then we can plug in the things we have right here.